Now we can apply these rules to extend this picture somewhat. We know the work done by the net force. Then what do we know? We know the change in the kinetic energy of the system. So I'm just going to indicate that by a single straight line, not related to anything else. These two are, if you know one, you can get the other. You don't need a triad. You don't need 2 out of 3 things. This determines this, and this determines this. Now, work done by conservative forces, well, that determines your change in potential energy, doesn't it? Because change in potential energy is equal and opposite to the work done by conservative forces on the system. Okay, work done by non-conservative forces, well, it isn't related to potential energy in any direct way. It's not related to kinetic energy in any direct way. However, we see that if we know this, well, if we know this, we know this. If we know this, we know this. So that if we know these two, we can find this one. Or if we know this one and this one, we can find this one. So we actually have a triad among kinetic energy change, potential energy change, and work done by non-conservative forces. So we can complete a triad there. And I'm going to do that, but I'm going to do it in a different color so that I can maintain just this equivalence. And then I'm going to put this together with, don't have a good way to get over there, so I'm going to kind of cut across these lines, and then I'm going to fly around over the top of everything here to indicate that this, and this give you what we call the more expanded work energy theorem, where the work done by non-conservative forces on a system is equal to the change in kinetic plus the change in potential energy. And I should probably include the words on here. Just to be very specific. And those words should be down here, but I'm going to be a little sloppy and leave it off. But if you're using this, you really want to be careful to include them to remind yourself of just how the forces are doing the work. Okay? Now, since gravitational, elastic, and other conservative forces do work that's equal and opposite to the change in potential energy due to those forces, we could say, okay, well, this delta W grav and change in potential energy by the gravitational force. We do the same with the elastic and the other forces. I'll do that off camera so you don't have to sit there and watch me do it. So, delta W elastic is directly related to delta PE elastic. They're equal and opposite, as you can tell by the basic principle. And delta W conservative other is equal and opposite, turns out, to delta PE other. So we have these direct implications, these direct equivalences in a way where this line doesn't mean equal and opposite because in this case it's equal. In this case, it's equal and opposite, and in all 3 of these cases, it's equal and opposite. We're just saying that this can be determined from this and vice versa. In this case, the 2 are equal. In this case and the other 3 cases, they're equal and opposite.